Welcome to my 59th tutoring session in A-level chemistry. In this video, we'll try and find out the answer for the question, why are compounds and pigments colored? The electromagnetic spectrum, it extends from the high energy gamma rays to the low energy microwave and radio waves. The energy of the electromagnetic radiation is given by the equation E is equal to h mu, where E stands for the energy of the electromagnetic radiation, h Planck's constant, and mu the frequency of the electromagnetic radiation. As you move from the high energy gamma rays to the low energy microwave and radio waves, we see that the wavelength increases. And conversely, as you move from low energy microwave and radio waves towards the high energy gamma rays, we see that the wavelength decreases. The visible region is part of the electromagnetic spectrum whose wavelength ranges from 400 to 800 nanometers. And this wavelength region can be pursued by the human eye and hence the name visible region. The wavelength of the ultraviolet region ranges from 200 to 400 nanometers, while the infrared region ranges from 400 to 4000 centimeter inverse. The most familiar form of electromagnetic radiation is the ordinary white light or the sunlight that can be dispersed by a prism into a spectrum of colors, that is VIBGYOR, referring to violet, indigo, blue, green, yellow, orange and red color. Now each color is associated with a certain wavelength and energy. And now you know why rainbow has 7 distinctive colors, because each color is associated with a different wavelength and energy. And the wavelength ranging from 400 to 800 nanometers can be pursued by the naked eye and hence the name visible region. The ordinary white light or the sunlight can be dispersed by a prism into spectrum of colors that can be pursued by the naked eye. And the wavelength of the visible region ranges from 400 to 800 nanometers. And remember, any colored substance will absorb radiation in this wavelength region, that is in the visible region. Now each color is associated with different wavelength and energy. Now violet color with a wavelength range of 380 to 450 nanometers has the highest energy, while the red color with a wavelength of 620 to 750 nanometers has lowest in energy. And these colors that fall in the visible region can be perceived by the human eye. Now let's talk about the natural and synthetic colored compounds. Now some of the naturally colored compounds are lycopene, carotene and chlorophyll, while the synthetic colored compounds are copper sulfate, phenylazobutanaphthol and para-hydroxyazobenzene. Now tomatoes are red color due to presence of the chemical lycopene. Carrots are orange in color due to presence of carotene, and leaves are green due to the presence of the pigment chlorophyll. Now copper sulfate solution is blue colored, while the synthetic dyes like phenylazobutanaphthol and para-hydroxyazobenzene are red colored. Now when a beam of visible light strikes a colored compound or a colored substance, certain amount of wavelengths of light are being absorbed while the rest of the wavelengths are being reflected. It is this unabsorbed reflect wavelength of light that strikes the retina of the eye and perceived as a characteristic color. And that is why the synthetic dyes like phenylazobeta, naphthol and para-hydroxyazobenzene are red colored, because these red colored synthetic dyes, they absorb certain wavelengths of light and reflects the red color. And this reflected red light, when it strikes the retina of the eye, it is perceived as a characteristic red color. So the important point to note here is the color of the chemical compound corresponds to the light that is not absorbed by the chemical. So it is the wavelength of light that is not absorbed by the chemical that is being reflected, is being perceived by the human eye. Now, in case of the lycopene chemical, we find nearly 13 double bonds present in the compound. Well, in case of keratin, there are 11 double bonds that are in conjugation with each other. Now, chlorophyll structure is bit complicated, bit complex. And azo-dyes, they are red colored. Now, let's deal with these colored substances. Now, the color of the chemical compound corresponds to the light that is not absorbed by the chemical. And compounds which absorb at wavelengths longer than 400 nanometers appear colored. Now, in case of lycopene, now from the structure of lycopene, we have learned that there are 11 conjugated double bonds in tomatoes that absorb at wavelength of 505 nanometers. While chlorophyll in green leaves absorb between 400 to 700 nanometers, and beta carotene in carrots absorb at 453 nanometers. So when you observe these three wavelengths, we can conclude that compounds which absorb at wavelengths longer than 400 nanometers appear colored. Why? Because wavelengths longer than 400 nanometers falls in the visible region. And remember, the visible region ranges from 400 to 800 nanometers. Now, tomatoes are red in color because they absorb most of the wavelengths, and the unabsorbed reflected radiation is the one that strikes the retina of the eye, perceiving it as a red color. And this reflected wavelength of radiation falls in the visible region. Now, talking about the chlorophyll pigment. Now, chlorophyll pigment, it plays a vital role in photosynthesis. And green plants are rich in chlorophyll. There are two types of chlorophyll. One is chlorophyll A and chlorophyll B. And these two pigments, they strongly absorb in the blue region as well as the red region or the visible region. Now, what you observe in this particular graph is that the chlorophyll strongly absorbs in the blue region as well as in the red region. So both chlorophyll A as well as chlorophyll B, they show strong absorption both in the blue region as well as in the red region, while there is no absorbance in the green region. And that is why this unabsorbed radiation that is reflected, when it strikes the retina of the human eye, it is perceived as a green color. And that is why leaves are green colored. So green plants, they show strong absorption in the blue region as well as the red region, but there is no absorbance in the green region. That is why this unabsorbed radiation in the green region is reflected which is perceived as green color. And what about the copper sulfate solution? Now you see there is no absorption in the blue region. So in case of copper sulfate solution, when a beam of visible light strikes the copper sulfate solution, there is no absorption in the blue region, while there is some amount of absorption in the green region, while there is strong absorption in the red region. So overall, so there is no absorption in the blue region, while there is strong absorption in the green and the red region. And that is why copper sulfate solution is blue colored. So a blue colored solution absorbs green and red wavelengths of light but reflects blue light. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.